Hello and welcome to the Military Standard 1553 testing suite. The project was sponsored by GE Aviation. Our faculty advisor were Dr. Brian Krug and Dr. Carl Pecora. Introducing the group, on the left is Jacob Vanderveen, an electrical engineering major, Joshua Johnston, another electrical engineering major, Nicholas Fernandez, an electrical engineering major and computer engineering major, Andrew Townley, an electrical engineering major, and Corey Sutter, a computer engineering major. Some background on the Military Standard 1553. It defines the mechanical, electrical, and logical functions of a serial data bus. Currently, only one person in the United States that reliably tests to the military standard, and he even tests Russian and Chinese equipment as well. The Military Standard 1553 has been used in the F-16, the F-15, and various other aircraft in the United States. A brief project overview would be, we'd like to make a testing suite that runs the pre-written protocol tests and records all relevant data to validate normal operating procedure of a remote terminal. We'd like to design new software and hardware to reliably run notoriously difficult tests that GE Aviation currently have problems passing, and effectively communicate between the testing devices and operator with a GUI for smooth testing experience. It's important to note here that we are providing the ability to run the lower level pre-written protocol tests, not trying to pass or fail these tests. An important portion of this is the GUI design. It should effectively interface all pre-written programs with the testing equipment. It should display all the needed information for the operator to know how to set up each test, and accepts individual test selection and displays all results in a report. On the left, you can see our GUI final design with a test failure or test pass colored box so the operator can easily identify which tests have been passed or failed, as well as a progress bar that shows how far the operator is through either a subset or a full test run through. It also includes a channel setup, a number of units, part number, serial number, model number, test interface description, the operator, customer information, and where you'd like to output the test logs and the equipment used, as well as the date and time of the test being run. Next is the hardware. Here, a big part was to create a new digital noise generator. This was created in VHDL and used a digital to analog converter, or a DAC, to output these voltages that were made in programming into the analog world. A comparison between the digital variety and the competitor's analog version is shown above. Right here, you can see the normal distribution of, on top, our digital noise generator and the competitor's analog version. Both are very normally distributed, with some peaks here and there. In the middle, you can see the FFT, or fast Fourier transform, of the digital and the analog noise generators. You can see one spike that was later ironed out of our digital FFT, and some ripple in the stop band, as well as a little bit in the pass band of the competitor's analog noise generator. Finally, on the right, you can see the power spectrum density graph, where you can see a very uniform distributed along the frequency, and again, fairly uniform distribution along the frequency. Thank you for watching, and if you'd like to learn more, please check out our long video on the same subject.